All right, so chapter 5, polynomials and factoring. So this is where, like Algebra 2, I really feel like kind of takes off. Now, Mr. O'Donnell, there's going to be a lot of like logic that you're going to have to use and a lot of thinking. So there's not going to be like just formulas that you have to memorize, okay? Or buttons to push. There's going to be like reasoning, and there's going to be like trial and error problems that you're going to have to work through, okay? So there's not going to be like a one size fits all here, okay? So that's moving forward into chapter 5. Now, I really like factoring, and I find it a lot of fun, but there's a lot of things that you gotta have to like try and pick up along the way, okay? And I'll do my best to explain them to you, okay? So, moving forward, the first section we need to talk about is exponents, everybody's favorite thing. Now, an exponent is the little number, and the big number is called the base. And the exponent means that's how many times we're going to multiply the base together, okay? So an exponent is used to represent repeated multiplication, all right? And this is where I'm going to kind of not go off on a tangent, but I'm going to kind of pre-teach some stuff. All right, so what I want you guys to do is just follow along. So I just need a white screen. So Sarah, the first thing I want to do is just make sure we're all okay with this. Sarah, what's your favorite number? 8? Awesome. Sarah, do you agree 8 to the third is 8 times 8 times 8? Can we agree to that? That these two things are the same thing? You're cool with that, right? That's all you need to know for this section. For like all of 5.1, that's all you need to know. Now, I know things get more complicated, but to do all the rules, this is it. First thing we need to kind of establish is this. E to the third times E squared, right? Now, do you know what that is? No idea. And that's okay. You do know what 8 to the third is, right? 8 to the third is 8 times 8 times 8. Agreed? 8 squared, we know, is 8 times 8. How many 8s do you have? How many? 5. 1, 2, 3, 4, 5. That's 8 to the fifth. Agreed? Now, Sarah, there has to be a shorter way to go from here to here, right? How can we get 8 to the fifth from 8 to the third times 8 to the second? Very good. We just do e to the 3 plus 2, which is 8 to the fifth. You okay with that? Awesome. Mr. Steiner, what's your football number?
My football number is 73.
73? Okay, that's nice. Give me a one-digit number. 4. 4 to the 7th to the 3rd. You ready for this? This is a lot. All right. What does 4 to the 7th mean?
4 times 4 times 4 times 4 times 4 times 4.
1, 2, 3, 4, 5, 6, 7. Right? So 4 to the 7th means 4 times 4 times 4 times 4 times 4 times 4 times 4, right? And then all of that to the third. But when I raise something to the third power, it means I have 3 of them, right? So I have 4 times 4 times 4 times 4 times 4. It's 5, 6, 7 times 1, 2, 3, 4, 5, 6, 7 times 1, 2, 6, 7. It's a lot of 4s, right? How many 4s is it? 21. Owen, but there has to be a quicker way to go from here to there. Like, I can't do that every time. 7 times 3, right? So to go from here to here, it's just 4 to the 7 times 3, right? That's easier, right? It's way simpler. Maggie, what's your favorite number? 3. To the what power? 3 to the third? All right. So 3 to the third over 3 squared. 3 to the third means 3 times 3 times 3, right, Maggie? 3 squared is 3 times 3, right? What do we do when we have the same thing on top and bottom? We cancel them out, right? What's left? How can I go from here to here quickly? 3 to the 3 minus 2. Very good, right? Easy enough. And the last one's kind of like a combination of both, okay? So I'll just pick 5 to the third over 5 squared. We'll say all of this to the fourth. So here with this one, what you can do is you can distribute this inside, okay? Sometimes it's useful in a problem like this. What I find very useful is to reduce the inside first and then do that. But in this case, we would do 5 to the 3 times 4 over 5 to the 2 times 4. And that is 5 to the 12th over 5 to the 8th, which is simply 5 to the 4th. Okay? You okay with that? Garrett, you okay with that? All right, awesome. There's 2 more things I want to go over. Garrett, what's your basketball number? 3? Really? I've already picked 3 like 8 times. 31? I like 30. All right. Garrett, 31 to, let's say, the 4th. Over 31 to the 4th. Ready for this, Garrett? I think you might be able to see where I'm going. Right, they're equivalent, right? And we have the same thing over the same thing, right? What does that turn out to be? 1, right? Now, but I just taught you this. When you have like a quotient with powers, what do we do to the exponents? What do I do with the exponents? Do you remember? We subtract them. What's 4 minus 4, Garrett? So these 2 things are the same. So anything to the 0th power, Garrett, is 1. And the last thing is this. Mr. Kitchen. Mr. Kitchen? Kitchen. Okay. Zach?
Yeah.
Zach, what's your favorite number?
My bad. I was in the bathroom.
It's okay. Zach, what's your favorite number?
2.
2. what do we do here, Zach? With 2 to the 4th over 2 to the 7th, what do I do with those two numbers? What do I do with the exponents?
Multiply by the exponents, then divide.
Yeah, what do I do? The 4 and the 7, what do I do with those two? Do I add, subtract, multiply, or divide?
Multiply.
Not multiply,
Divide.
not divide,
Man, you got me here.
subtract. So we subtract these two, right? So we do 2 to the 4 minus 7. And that's -3. But on the other side, we have 1, 2, 3, 4 2's on top, and 1, 2, 3, 4, 5, 6, 7 on bottom. And this cancels with that cancels with that cancels with that, and that cancels with that. And I'm left with 1 on top because everything canceled, and I have 3 on bottom. So notice 2 to the -3rd is equivalent to 1 over 2 cubed. All right, now we're ready. All right, so with exponents, we have rules of exponents, but you guys already know them. The product rule. If we have repeated multiplication, meaning 4 times 4 times 4 times 4, we can simply write that as 4 to the 4th. Okay? That was the rule that Sarah and I agreed upon at the start. In terms of variables, a times a times a times a times a is a to the 5th, because I have 1, 2, 3, 4, 5 a's. Now, the product to a power, okay? So this one is going to be like 3 squared times 3 cubed. That was the one where we added. We did 3 to the 2 plus 3, and we got 3 to the 5th. In terms of variables, this is like b squared times b to the 5th. Well, that's b to the 2 plus 5. And that's b to the 7th. I would just add the 2. Jagger, are you okay with that? Power to a power. Well, this is going to be something along the lines of, say, 2 to the 3rd to the 6th. So I would simply do 2 to the 3 times 6 and get 2 to the 18th. In terms of a variable, doesn't change too much. Okay, let's say c to the 4th, and the whole thing raised to the 5th. I would just do c to the 4 times 5, which is 20. So far, so good. Quotient rule. This was like we have 5 to the 6th over 5 to the 3rd. We would do 5 to the 6th minus 3, which is 5 to the 3rd. So we subtract it. And we saw that when we were working through all of kind of like the pre-learning stuff. In terms of variables, this would be like d over 7 over d over 4. You just do d to the 7 minus 4, and that gives us d to the 3rd. And then I'm not a big fan of the quotient to a power, okay? But if I do have a quotient to a power, say something along the lines of, say, 4 squared over, I don't know, 3 cubed to the 5th, and I'm picking this specifically what I like to do first is I like to see if I can simplify anything in those parentheses to kind of make my life easier. If I can simplify it, I'm going to simplify it. If I can't, I move on. So here, 4 and 3, I can't really do much with. So I'm going to do 4 to the 2 times 5 over 3 to the 3 times 5. And that's going to be 4 to the 10th over 3 to the 15th. And I'll just use A and B here. Let's say 2 to the 3rd, or A to the 2nd, B to the 3rd, to the 4th. We just do A to the 2 times 4 over B to the 3 times 4. That gives me A to the 8th over B to the 12th. I know there's a lot of random stuff going on, but if you break things down to what they mean, you can always figure it out. All right. So here, multiplying exponents and powers to a power. So what a lot of kids struggle with is whether to multiply or add, but it really comes down to the coefficients where they struggle. It's not necessarily the exponents, but it's the coefficients. So be careful with that stuff. So even though I'm going to add my exponents, I still need to multiply my 5 and 3. So I do 5 times 3, that's going to give me 15. And then here I have 1x, and then I have 2 x's there. So if I have 1 and 2, I'm going to have 3 x's. And that's the way I'm thinking about it. Okay? I have an x times x times x. That's x to the 3rd. Okay? But I'm thinking in my head, this means I have 1x here. This means I have 2 x's here. And through multiplication, I have x to the 3rd. And then y has nothing to combine with. So it's just y to the 4th. In a question like B, Garrett, what's my coefficient of this second term? 1. So I'm going to have, when I'm moving forward and doing this problem, I have -3 times 1, that's -3. Garrett, how many x's? 8. Because I have x to the 3rd times x to the 5th, that's x to the 8th. Maggie, what's my coefficient in C for the first term? That's the second term. 1. So I do 1 times 2, that gives me 2. How many u's? 3, so it's u to the 3rd. How many v's, Maggie? First and second, you can combine them. 3, so it's v to the 3rd as well. Emily, Greg, you doing all right?
Yes.
All right. Now, with question D, Emily, is the -3 in the parentheses?
No.
No. So when I go ahead and I distribute this 2, it doesn't go to that 3. So I have x to the 2nd power. That's x squared. Y squared squared. Emily, what would y squared squared be?
Is it y to the 4th power?
Yes. And then I do not have anything to multiply that -3 with. So it's -3 x squared y to the 4th. Now, Mr. Kitchen, what's the difference between E and D?
And E and D.
E and D.
The three's outside the parentheses, and then the three's inside.
Very good. In E, the 3 is inside the parentheses. So, Mr. Kitchen, what is -3 squared?
9.
9. Awesome. Because -3 times -3 is 9. Mr. Kitchen, what's x squared? I know it's a silly question.
Isn't it just x to the second?
It is. It's just x squared. What is y squared squared?
Y to the 4th.
Y to the 4th. Awesome. F, notice -3 is going to pair up with the 1. So it's -3. Oops, sorry. Here, don't forget you have the 2, so it gets distributed inside. So it's going to be -3 squared, which is 9. X squared, which is x squared, times x to the 5th. The 9 doesn't have anything to combine with, so I have 9. X squared, x to the 5th, that's x to the 7th. Mr. O'Donnell, exciting stuff, huh? Dude, I love this stuff. It's almost as exciting as watching the Jets versus Jacksonville. It's a very exciting game. All right, now I actually almost find division easier than the multiplication ones. With division, Caitlin, what is 14 divided by 7?
2.
2. And what's 8 to the 5th divided by 8 to the 2nd? There'd be 8 to the what power?
4th.
What's 5 and 2, right?
7.
Well, remember, we're dividing, so what do?
Well, wait. Can you repeat that?
Yep. So we're doing quotients now. So we have 8 to the 5th over 8 to the 2nd. So with multiplication, we added. With division, we're going to,
Subtract it.
yeah, so it's 5 minus 2,
3.
3. So this is going to be 2a cubed, b to the what power?
1.
There you go. Jagger, because I know you have a calculator. 18 and 20. I know they don't divide out perfectly like 14 and 7, right? So what's 18 over 20 in a fraction? Math, enter. Hit math, enter, because I need it as a fraction. 9/10. Now, Jagger, x to the 7th over x to the 3rd is x to the what power? 4. And it's up top, right? Because there's more x's up top. Y to the 4th. Just y to the 4th, right? So this just simplifies to that. Mr. Kinfu. Mr. Kinfu? All right. Mr. Emmy.
Yes.
Mr. Emmy, what's -18 over -6?
Let me get. Isn't it +3?
3. Now, what's m to the 3rd over m, Mr. Emmy? So remember, we subtract the exponents, so it's 3 minus 1,
M to the 2 or
n
second.
to the second. And n to the what power?
9.
Well, remember, we're subtracting
3 or Q.
3. All right. So I'm going to stop there because, and I want this to go on YouTube, I got to take attendance again because I can hear that some people are leaving. So tell your friends, don't leave early.